This is call and register. The purpose of this lab was to find the mass of a black hole based on a star's motion, and then determine the initial velocity required of a ship to orbit the black hole and not fall back to the planet it launched from. The models used were a glow-script computational model, and the principles involved were Newton's second law / the momentum principle and the universal law of gravitation. The main result was that the black hole had a mass of 7.39 times 10 to the 33 kilograms, and the initial velocity of the spaceship is negative 5.2 times 10 to the 6 meters per second in the x direction, and 6.9 times 10 to the 6 meters per second in the y direction. The main ideas used in this lab are Newton's second law of motion, the momentum principle, and the universal law of gravitation. In this lab, we need to use the universal gravitation equation and the velocity and position update formulas. Since we are in space, the only force acting on the ship is gravity, so F net equals F grav. If F net parallel is in the same direction as the motion, the ship is speeding up, and if F net perpendicular changes, the direction of motion changes. In the bottom left, we see the formula for the force of gravity, and in the bottom right, we see velocity update and position update. The system and surroundings in this experiment, the system in the black hole is, or the system in this experiment is the black hole, and the surroundings are the star / planet the ship is launched off of. The initial conditions, the star had a mass of 2 times 10 to the 30 kilograms, delta T equals 86,400 seconds, and the gravitational constant equals 6.7 times 10 to the negative 11. The coding. Using the source code provided, I produced a model that predicted the mass of the black hole and then determined the initial velocity of the spaceship required so that the spaceship would not crash into the black hole or fall back to the star. And we see this in the bottom left. Similarities and difference. The model should be pretty accurate to what would actually happen in this scenario, as it uses the same constraints or the same constants and forces that happen in the real world. Possible sources of error. To make the model more accurate, it needs to run for longer. This would make the predicted mass of the black hole and the initial velocity of the spaceship more accurate. What if? In order to orbit the black hole, the ship needs to have a velocity with a slightly larger y component and a slightly smaller x component. In this case, the initial velocity would be negative 2.9 times 10 to the 6 meters per second in the x direction and 7.06 times 10 to the 6 meters per second in the y direction. And the orbital velocity of the planet is 7.037 times 10 to the 6th meters per second. What does this mean? This means that the net forces are all the forces in the system, whereas the momentum is just mass times velocity. So this would mean that the momentum is going to be much easier to find than the net force in any given instance. Thank you.